Hi there, welcome back in case you're new. My name is Julius and thank you for coming around. Today we're going to look at how to calculate empirical formula from a given percentage composition of each of the elements in a compound. In our previous video, we look at also how to get the empirical formula from masses given, and without further ado, let's dive into the video. So here, if we're given a question of this type, it's easy to calculate. First thing is to go through and read to find out the elements that compose that compound. An oxide of silicon. Now when you hear about oxide, meaning that metal reacts with oxygen to produce that compound, which is oxide. So let's move on. Was found to contain 47% by mass of silicon. What is the empirical formula of the oxide? Now here we're only told the percentage composition of silicon, and we know that oxide is from oxygen. Therefore, the remaining percentage would be the one for oxygen. And since 47 is less than 53, to make it 100, then we know that oxygen contains the greatest percentage. Therefore, the atomic mass of silicon is 28 and oxygen is what? 16. So let's start here by saying elements. So we can bring the elements here and put them horizontally. So the first element here is silicon. So if you wish, you can write in short form like what we have here, but let me first write in full and then I give the abbreviation near it. So therefore we have Si as representing silicon, and oxide comes from oxygen, so we can give here oxygen with also capital O. Now the percentage composition will be given corresponding to the elements. So let's have here percentage composition. So for silicon, our percentage composition is 47. And since we've written here percentage, we don't need to put also here. And next, in oxygen, we need to show how the answer comes about by subtracting our 47 away from 100. So therefore, if we subtract that, we get 53. And that is the percentage composition of oxygen. So the next one here, we need to align the relative atomic mass. So the relative atomic mass for silicon is 28 and the one for oxygen is 16. So the next thing here is to get the number of moles. Now the number of moles is given by the percentage composition divided by the relative atomic mass. So for silicon we have 47 over 28, and for oxygen we have 53 also divided by 16. Now let's go ahead and get a calculator to work out this number of moles. So 47 divided by 28 gives us 1.68. Let me round to two decimal places. Now let's move on also and work for oxygen. We have here 53 divided by 16, and that gives us 3.312. So to also two decimal places, a 3.31. Now, after reaching to this stage, what happens next? The next thing here is we look at this number of moles and we choose the one that is smallest, and of course 1.68 is smaller than 3.3, so we divide by the smallest ratio. Now here 1.68 divides also 1.68, and here 3.31 divides 1.68. And why do we divide? Because we need to get mole ratio. The first one gives us 1, and the next one from a calc we have our 3.31, and if the added version divide by 1.68, and this gives us 1.97. Now there's one thing we need to also note here. If you have this type of mole ratio, a mole ratio is always whole number. So since number of moles are always considered as whole numbers, we need to look at this method of rounding where most people don't talk about it. So let's talk about it slightly here. If we have fractions like 0.1, 0.2, 0.3, 0.4, and let me write another one in a special color, 0.5. Let's continue putting in the rest here, 0, 0.6, 0.7, 0.8, and 0.9. So what happened? We need to categorize this fraction, and the one in the middle is still same, is alone. So what happened in these scenarios of the first one? So you realize that for a fractions that are like this, we call them minor fraction. So here we call this as major fractions. And the one in the middle is mid fraction. What do I mean by mid? It is gotten in the middle of these fractions. Here, dividing it into two equal parts, 4 before and 4 after. Now, there's a few rules that we need to use when rounding off. Now, when you look at this fraction, it's like, let's forget about this one first and say 0.9. Where does it lie? Here in the major fraction. So, for this 0.6, 0.7, 0.8, and 0.9, we take one of this value here and we add to the next whole number, because this side is the fraction and the other one are whole numbers. So taking 1 in each one of them, if you get any type of this, you will add here 1. Now for the one in the middle, what we do is to multiply it by 2. Why? Because if you multiply 0.5 by 2, you will simply get a whole number. So that is treated in a special way. That is why it is in the middle. Now, the minor fractions, what we do is to transcade. To transcade means to just cancel it off and leave it away. So for that case, we don't need to take any to add to the next fraction. Now let's take a look at our case here. Of course, here we have 1, it's okay. Now this side here we have 1.9. Where does it lie? Obviously in the major fraction. And since it is in a major fraction, so we don't worry whether it is 0.8, 0.7, or 0.6. What you need to know is to take 1 and add to the whole number. So let's do that. Let me write here that we have our mole ratio. So this mole ratio is 1 is to 2, because we have taken 1 and added to this one. Now after getting this mole ratio, it will look like the number of atoms for our elements up there. So we can form our compound by saying Si representing silicon is having 1 here, and then for 1 we don't need to write, we just simply ignore and we bring in oxygen. So oxygen has atoms of 2. Therefore, as you study chemistry, what do you think is the chemical name of this compound SiO₂? Please tell us in the comment section and then keep the conversation going. And before we move on to the next question, because I've prepared for you 2 good questions here, if you have not subscribed to the channel, go ahead and subscribe in order for you not to miss this kind of questions. At Caltex Academy, we bring for you varieties of topics from different subjects like chemistry, physics, and mathematics. So let's move on to the next question. Yeah, in our question number 2, we have it here that says the percentage composition by mass of an oxide of iron is 70% and 30% oxygen. We're still also dealing with oxides. Determine its empirical formula when we're given the atomic mass of iron to be 56 and oxygen is 16. So the same way we have tackled the other question, now what we do is to have these elements arranged. And our elements are, this time I'm writing the symbols. We have iron and oxygen. So the next thing here indicate our percentage composition beneath this. So we say percentage composition. So for iron is 70 and for oxygen is 30. Now the next one here is their relative atomic mass. So for iron is 56 and for oxygen is 16. And next is number of moles, which is calculated from the percentage composition divided by relative atomic mass. So here we have 30 divided by 16. And we also get our calc inputting 70 divided by 56. And we get the result of 1.25. Doing the same to the next one here, we have 30 by 16 and we get 1.875. Now after this, we also look at this number of moles and divide by the smallest. So our smallest happen to be 1.25. Also here, 1.875 divided by the smallest ratio, 1.25. The first one goes to 1 automatically, and here this one goes to, this is our calc, to divide our answer by 1.25, and we get 1.5. And exactly following our question number 1, this one falls on mid-fraction. For mid-fraction, we have to multiply each of these ratios by 2. If I multiply this by 2, you can also do the same here in order for you to balance it. If you multiply only this side here, then you'll have made a great mistake. So here, let us go on and have our mole ratio. So this becomes 2:3. Therefore, we can now move on and write the empirical formula. So the first element is iron, and we bring in our 2 down here, and the next element is oxygen, and we bring our 3 here. That becomes a compound, or the simplest formula. We know that iron exists in 2 oxidation states. Which of these oxidation states have written this compound in? And what is the name of this compound? Please drop your answer in the comment section, and see you in the next video. Peace out.